Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department, IIT Kharagpur. I welcome you all to this NPTEL course on traction engineering. Today I will try to cover pressure sinkage relationship. For this I will I'll demonstrate a experimental setup where I will try to clear the concepts like what is the setup which is used for measuring plate sinkage, and then you will try to find out what is the cohesive modulus of sinkage, frictional modulus of sinkage, exponent of sinkage. And these parameters are important and they are related to bearing strength of soil. So that's why you are interested in measuring these parameters. In a pressure sinkage test, what we are measuring is how much pressure we require to force a plate. Plate could be a rectangular plate, plate could be a circular plate, and that should simulate the contact area of a tire. Now, it is better to take a circular plate because when you apply a load, it becomes uniformly distributed. If you take a rectangular plate, the corners are dead points. So that's why pressure is not uniformly distributed. So what we have done is we have taken three different circular plates of diameters 25 centimeter, 30 centimeter and 35 centimeter. Now these plates are put on the soil and then we try to apply a force using a hydraulic cylinder, and the force which is applied, that is measured with a load cell, and the force data and the corresponding sinkage data which is the sinkage is measured using a potentiometer. So these data are recorded in the computer, and now I'll try to show those data and how they will be utilized to find out the modulus of sinkage and exponent of sinkage. So pressure, which can be calculated by dividing force with the corresponding area. Area in this case will be area of plate 1, plate 2, plate 3, like that. So there will be three different plates you have taken. So P will be calculated. Then P is related to Z by an exponential relationship. So that means P is equal to Kz to the power n, where K becomes your modulus of sinkage and n is the exponent of sinkage. Now modulus of sinkage is again divided into two parts. The first part is your cohesive modulus of sinkage, which is Kc, and the second part is your frictional modulus of sinkage. This cohesive modulus of sinkage is dependent on the plate dimension, and K phi is independent of the plate dimension, that means loading area. The N represents the soil characteristics, whereas K represents both soil as well as the loading area characteristics. It is a rectangular plate or a circular plate which simulates the contact area of a tire, and that has to be forced to enter into the soil. So what we are going to measure is the force which is required to press it and what is the corresponding sinkage. So once we know the force divided by the area of the plate, that will give you pressure. So and the corresponding sinkage we will try to measure. So I will try today with three plates of different diameter. This is of 25 centimeter, or the other one is 30 centimeter, the third one is 35 centimeter. Each has its own weight, like the 25 centimeter plate has a weight of 431.95 gram, 30 centimeter plate has a weight of 620.51 gram, and 35 centimeter plate has a weight of 851.18 gram. So these are to be pressed into the soil with the help of a hydraulic arrangement. So I will give you the details of the setup. Then I will show you how a plate is pushed into the soil to find out the pressure and sinkage parameters. I will now show you the setup which is used for measuring the pressure of pressure required to press a plate into the soil. The setup comprises of a plate which is kept over the soil surface, This is the plate which has a diameter of 30 centimeter. Then this has to be pressed using a shaft. This shaft is connected to the hydraulic cylinder. This is the hydraulic cylinder. So in between the shaft and the hydraulic cylinder there is a load cell that is going to measure how much force you are applying. So the corresponding sinkage has to be measured. So we have an arrangement like potentiometer which is shown here. This potentiometer will be used to measure the sinkage. That means when there is a sinkage, there will be a change in resistance, and that has been already calibrated, by which you can know how much depth the plate has entered. So now I will show you. So this shaft is now in contact. There is a crossbar provided so that we will apply more or less an uniform pressure. So I have applied some force and the plate has now entered into the soil. So now I will remove the shaft. So similar exercise I have to carry out for 3 different plates. And the data which are acquired using this load cell and the potentiometer, that will be stored in a computer using a data acquisition system. Now the data which you obtain related to plate 1, that is diameter 25 centimeter, this is the sinkage values, these are the corresponding force values, and then force were converted to pressure by dividing its area pi r square. So these are the pressure data which you got. Now we try to plot this pressure data against the sinkage data. So sinkage we have taken on the x-axis and pressure you have taken on y-axis. Now what we observed here is this is fitted to a power equation which can be given as pressure is equal to 769.4 kilonewton per meter raised to the power n plus 2 and into x is your sinkage. So sinkage raised to the power 0.798. So here we got 2 values. One is k value, the other one is n value, and we have denoted it as k1 and n1 corresponding to plate 1. So similarly we got data for a diameter 30 centimeter. So these are the sinkage data, these are the force data which you got, then we converted into pressure data. So this pressure data is plotted against the sinkage data, and again we saw that this is best fitted to by an power equation where pressure is equal to 722.16 into sinkage raised to the power 0.8219. So that means the modulus of sinkage value which is denoted as K2 and the exponent of sinkage value which is denoted as N2, they are found out from this equation. Again we tried with another diameter plate which is 35 centimeter. We got the sinkage data here, we got the force data, and then force divided by the area of the plate, so that will give you the pressure data. So now we try to plot pressure versus sinkage. So what we observe here is again a power equation which will be best fitting the observed data points. So pressure is equal to 684.89 into sinkage raised to the power 0.7661. So we got modulus of sinkage value 684.89 kilonewton per meter raised to the power n plus 2, and then exponent of sinkage value we got 0.766. So now all the 3 sets of values which we obtained for 3 different plates for the same soil condition, we try to plot in one graph. So these are the results which you can see. The blue line indicates the data related to 25 centimeter. The orange line indicates, the orange dots are indicating the data related to 30 centimeter plate radius, diameter plate, and the gray ones representing the 35 centimeter diameter plate. So what we observe here is these three lines, they are not parallel. They are having a slope. Each slope is different. Now question arises, for the same soil condition, we have utilized three different plates and we are getting three different slopes, which is possible because since we are doing experimental measurements, so the soil condition may not be that much uniform, so that's why we are getting three different slopes. So Baker has suggested, because the equation which is given, that P is equal to kz to the power n, that has been proposed by Baker. So now he has suggested that if you are getting different slopes, then the best way is to take the average, which will be representing the average exponent of sinkage of that soil. So we found out the slopes N1, N2 and N3. Then we took the average of N1 plus N2 and N3. So that becomes the, the exponent of sinkage for the soil for which we carried out the test. Now comes how to find out the frictional modulus of sinkage, the cohesive modulus of sinkage, because we have got data related to modulus of sinkage. Now we know that modulus of sinkage is related to this frictional modulus of sinkage K phi and Kc by a straight line relationship. That means K is equal to Kc upon B plus K phi. So if you are plotting K versus 1 upon B, then the slope will give you Kc value and the intercept will give you K phi value. So the K value which we got for three different plates in terms of K1, K2 and K3, we tried to plot against 1 upon B. So we got 3 points. Then we try to best fit this three observed points. So what we observed is there is a straight line which can very well predict these values. So the straight line is 36.724 into 1 upon B. This x is nothing but 1 upon B plus 475.76. That means the intercept is 475.76, which is nothing but your frictional modulus of sinkage, and the slope is nothing but Kc, which is equal to 36.724. So, and we also calculated the average exponent of sinkage, which is summation of these three, and we took the average, so that way we got around a value of 0.795. So finally, what we have arrived is Kc is equal to 36.72 kilonewton per meter raised to the power 1.795, and K phi is equal to 475.76 kilonewton per meter raised to the power 2.795. This Kc unit and unit of K phi, they are not same, as we know that they are dependent on exponent of sinkage. So that's why there is a variation. So in one case we are getting 1.795 meter raised to the power 1.795. In the other case we are getting meter raised to the power 2.795. Now these are the values for a sandy clay loam soil which is around, the moisture content is around 10% dry basis. So the plate sinkage test, as I said in the beginning, which indirectly give you the response of the terrain. Terrain means the soil, how it is behaving when it is loaded with a tire. So these parameters are required, and this is one of the techniques which is used for measuring this response of the terrain. There are two methods basically, which is called bivameter technique, and out of this bivameter technique the two methods are, one is plate sinkage test, the other one is shear annulus test. So shear annulus test will give you the shear stress which is causing the failure of the soil, maximum shear stress which is causing the failure of the soil. So, and the plate penetration test is going to give you the bearing strength of soil. So we have utilized this plate penetration test, and then we try to find out the exponent of sinkage and modulus of sinkage. Again, modulus of sinkage is nothing but your cohesive modulus of sinkage and frictional modulus of sinkage. So these are the three values which we obtained by carrying out the plate sinkage test. So the values which you got, that is valid for a sandy clay loam soil. The moment you change the soil, then these values may change. So it is these parameters are dependent on type of soil and also the moisture content. That is important. So whenever we try to mention these values, we have to mention that, okay, these are the values which you obtain at a moisture content of this. That has to be mentioned. So this is how we carry out the plate sinkage test, and I hope you will understand how to calculate Kc, K5 and N for a given soil condition.